Welcome everyone to the channel, and today we're going to discuss about automatic transmission. Going to briefly discuss what's an automatic transmission, its advantages, and some of the components found in it. Automatic transmission introduction. The main aim of electronic controlled automatic transmission, commonly known as ECAT, is to improve conventional automatic transmission system in the following ways. 1. Gear changes should be smoother and quieter. Improved performance, reduced fuel consumption, reduction of characteristic change over system life, increased reliability. Maybe you should note the 5 advantages of an electronic controlled automatic transmission, ECAT. The actual operation of an automatic gearbox is beyond the scope of this scope. However, the important points to remember is that gear changes and lockup of the torque converter are controlled by hydraulic pressure. In an electronic control automatic transmission system, electronic controlled solenoid valves can influence the hydraulic pressure. Most Ecat systems now have a transmission ECU, electronic control unit, that is in communication with the engine control electronic transmission by CAN network, control area network database in many cases. The system as a whole consists of a number of sensors providing data to the electronic control unit, which in turn is able to control a number of actuators or output devices. We'll briefly discuss some of the components in the ECU. Well, the ECU is made up of inputs and outputs. The inputs to the ECU include the mode select, engine speed, normal or park switch, throttle position, overdrive switch, cruise electronic control unit, speed sensor 1, speed sensor 2, input speed sensor, kick down switch or coolant temperature. The outputs include solenoid valve 1, solenoid valve 2, lockup solenoid, clutch pressure solenoid, ignition control, diagnostic output. Within the electronic control unit, data from the sensors are used. Within the control unit, data from the sensors are used to refer a lookup table, mainly as a function of engine speed and vehicle speed. Data from another sensors are also taken into consideration. Actual gear shifts are initiated by changes in hydraulic pressure, which is controlled by solenoid valves. The two main control functions of this system are hydraulic pressure and engine torque. The temporary reduction in engine torque during gear shift allows smooth operation. This is because the peaks of the gearbox output torque can be suppressed, which causes characteristic surge as the gear changes on conventional automatics. Engine torque control can be a throttle movement, fuel cutoff, or ignition timing retardation. The latter seems to have proved the most appropriate in modern systems. Basic pressure control. Pressure is set to optimum level for speed of the gear shift. This can be adapted as the system learns the idle pressure by monitoring shift time and changing of pressure accordingly. Feedback control. This detects the variation of conventional speed of an input shaft from the target value and adjusts pressure to maintain the control. Complectional control. Torque converters, hydraulic pressure is reduced momentarily so that as the engine torque output control is reduced, the potential surge is prevented. Because of this control function, smooth gear shifts are possible and due to learning ability of some electronic control units. The characteristics remain constant throughout the life of the system. Torque converter lookup. The ability to lock up the torque converter has been used for some time, even on vehicles with more conventional automatic transmission. This gives better fuel control, quickness, and improved drivability. Lock-up is carried out during a hydraulic valve, which can be operated gradually to produce a smooth transmission. The timing of a lockup is determined from the electronic control unit memory in terms of the vehicle speed and acceleration. In summary, I'll summarize what we've talked about. The use of integrated intelligent control of both engine and transmission allows considerable improvement in operation of automatic gearbox. Improvements are possible to efficiency, performance, and smoothness of the operation. Extra facilities become available to the driver, such as being able to select the desired mode of operation. This can be a choice between, for example, performance and economy of the fuel. The tie-up between engine control and transmission control helps to illustrate how it's becoming more difficult to consider vehicle systems as isolated units and how more consideration are given to overlap of system boundaries. Consider subscribing to the channel, hit the notification bell for more videos that are more informative.